surface 2, and this is a curved surface. What is the flux through each surfaces here? So first we'll calculate flux at 1. How the n cap? I should define the n cap here. How the n cap? So n cap for this, it will be in this direction. It's a closed cylinder. The n cap for this will be like this, and the n cap for surface 3 will be in this direction. So what it is? Closed cylinders. Now first we'll get into the flux at flux linking the one should be equal to E into E bar dot S1 bar. E S1 cos 180 degrees. E, what is S1? Pi r square. So what is the flux? Minus E pi r square. What is the area of cross section of this cylinder? Pi r square, because r is the radius, capital R, I'll write it. Yeah. Similarly, flux linking the second one, E bar dot S2 bar. How is n cap? N cap is in the direction of E bar. So what is the angle between them? Cos 0 degrees. So they should be equal to minus E or plus E pi r square. E bar dot S3 bar. So they should be equal to E into what is the area? 2 pi RL cos 90 degrees. So this should be equal to 0. So what is the flux linking this lateral surface? Shall we call this a lateral surface? This call like a lateral surface. This call like a plane surface, or you can say like a cross section of cylinder. So what is the flux through this lateral surface? Will be 0. Any reason for that? Because E bar everywhere is perpendicular to n cap. Now what is the net flux linking the cylinder? Phi 1, phi 2, phi 3. So this should be equal to minus E pi r square, E pi r square plus 0. Altogether resultant will be 0. So when you immerse a structure in a uniform electric field, this is what happens here. If the field is non-uniform, E equal to E naught x, so the lines of force will be in the direction, then the net flux linking through the cylinder will be non-zero definitely. So same cylinder, let me bring. I can draw easily another diagrams. Okay, now let me bring another type of field. Now, what do you say about net flux? Should be non-zero in this case. Earlier net flux was 0. It all depends upon the type of field in which we are immersing. Why in this case? So what about the flux by 1 non-zero, flux by 2 non-zero, flux by 3 also non-zero? Can we calculate that, as we need some information? If you have a few more information, if they give better regarding the direction of the field, the magnitude, how it varies, no, we can find out mathematically. But diagrammatically, I can just say that the net flux will be non-zero now. So first I'm just focusing you to learn the flux. Again, what is the flux? Once again, what is the flux? Nothing but the lines of force. So how many lines of force are passing through? Net lines. How many lines of force are entering? 1, 2, 3. Those many are leaving. Able to understand? No. How many lines of force are entering? 1, 2, 3, 4, 5. How many are leaving? 1, 2, 3. Number of lines of force entering equal to number of lines of force leaving. Then net flux through a surface or through a structure or through a body, we say 0. What about here? The number of lines of force, definitely what I can say that. In fact, it will be here non-zero. So rather than saying that how many lines entered, how many left, the difference of that, I'll just say that I'll calculate flux. If it is non-zero, so what does it mean? The number of lines of force entering is greater than those are leaving. So like this, what happened? The better picture of lines of force we can express with the help of a flux concept. Any doubts you can clarify?